Hello students. At present, we are crossing through a very tough time. The whole world is facing a challenge, that is COVID-19. And you know, the only way to fight against this challenge is to stay home. We are in a stage of lockdown for nearly 1.5 months. And naturally, we are detached from our regular classroom. This online class is a try to bring you back in this teaching and learning process. Today's video is made on a very simple and important topic of physics for the students of class 10, keeping in mind the scope of the syllabus of ICSE. Here I am going to discuss about work and energy. You know, in our daily life, work refers to some sort of physical or mental exertion. But according to physics, work is said to be done only when a body moves under the influence of a force. So students, first we have to see what is work. Work is said to be done only when the force applied on a body makes the body move, that is, there is a displacement of the body. Here you can see two pictures. In the first figure, the man is pushing a wall. Obviously, the wall will not move. So, the man, in spite of applying some force, does not do any work. But in the second figure, the man is pushing a car and the car is moving in the direction of the force. So the man is doing some work. The next question is, work is a scalar or a vector quantity? Work is a scalar quantity, because it has magnitude but it has no direction. So how can we find the magnitude of the work? Work is the product of force and the displacement of the point of application of the force in the direction of force. But it may happen that the direction of the force and the direction of the displacement may not be same. In that case, you can see the first figure. Here, the force and the direction of the displacement are not same. The displacement is inclined to the direction of the force with an angle of theta. So, we have to consider the component of the displacement which is along the direction of the force, that is the cos component of displacement. So the component of displacement which is in the direction of the force is s cos theta. So the magnitude of work here can be found by W is equal to F into s cos theta. That is, we have considered the first case, that component of displacement along the force. And in the second case, you can see that we have considered the component of force along the displacement. So here we have to consider the cos component of force, that is F cos theta, which is along the direction of the displacement. So here work can be found by F cos theta into S. So ultimately we can say that magnitude of work is actually W is equal to F S cos theta, where theta is the angle between displacement and force. Depending on the value of theta, we can find the magnitude of work. Work is a physical quantity whose SI unit is joule and its CGS unit is erg. If you find the relation between joule and erg by the process of conversion, you can find that 1 joule is equal to 10 to the power 7 erg. So 1 joule of work is said to be done when a force of 1 Newton displaces a body through a distance of 1 meter in its own direction. Now comes energy. We know that work and energy are very closely related to each other. So energy is the ability to do work. Its SI unit is also joule. We know that in our universe, energy has different forms. You can see here that there are many types of energy like solar energy, heat energy, light energy, chemical energy, hydro energy, electrical energy, nuclear energy, geothermal energy, wind energy, sound energy, magnetic energy, mechanical energy. And the main thing we must say that energy can neither be created nor destroyed. It can only be converted from one form to another. Here we will discuss in detail about mechanical energy and its different forms. There are two types of mechanical energy. One is potential energy, the other is kinetic energy. The energy possessed by a body due to its state of rest or of motion is called mechanical energy. Potential energy is the energy possessed by a body at rest in its changed position or change in size and shape is called the potential energy. It has two forms. One is gravitational potential energy, the other is elastic potential energy. The potential energy possessed by a body due to the force of attraction of Earth on it is called its gravitational potential energy. The gravitational potential energy of a body at a point is the amount of work done by the force of attraction of the Earth in bringing that body from infinity to that point. Its magnitude can be found by the product of mass, acceleration due to gravity, and height. So we can say that gravitational potential energy is equal to m into small g into h, where the small g has a value of 9.8 into 9.8 meter per second square on the surface of the earth. The next is elastic potential energy. The potential energy possessed by a body in the deformed state due to change in its size and shape is called elastic potential energy. For example, the energy possessed by a stretched rubber band, the next form of mechanical energy is kinetic energy. The kinetic energy possessed by a body due to its state of motion is called the kinetic energy of the body. For example, a fast moving stone has the capacity of breaking a window pane on striking it, and thus it has kinetic energy. The magnitude of kinetic energy can be found by the formula half m into v square, where m is the mass of the body and v means velocity of the body. So we can say kinetic energy is equal to half into m into v square. Students, you have already learned about momentum, which is a physical quantity and can be found by the product of mass and velocity. Here we will find the relation between kinetic energy and momentum. Just now we have read about kinetic energy, that is kinetic energy equal to half mv square, and momentum P equal to m into v. From this expression we can have v is equal to P by m, means momentum by mass. Putting this value of velocity in the expression of kinetic energy, we can get a new expression, that is kinetic energy equal to half into mass into momentum square by mass square. So ultimately we can get an expression kinetic energy equal to half into P square by m. This is the relation between momentum and kinetic energy. Children, here is the end of this topic. So we have come to the end of today's topic, and I hope you all have understood what is work and energy. Here is a worksheet for your related topic, and you can solve these questions and have an idea about the today's topic. So students, thank you. Stay home and stay safe.